Hi everyone. In addition to my other task at Code Alpha, my third project involves predictive modeling using linear regression. Specifically, I am applying this concept to car insurance modeling to predict risk and optimize insurance premiums. I'll walk you through the objective, methodology, and yearly result of this predictive modeling project. Before getting dive into it, I'd like to give you a short overview of car modeling, how it refers. The car modeling refers to the use of statistical and mathematical model to accurately predict events such as frequency of claims, the severity of claims, or the total cost associated with claims, which in turn help in pricing insurance products, managing risk, and optimizing business strategies. If you want to learn how to perform car insurance modeling, this project is for you. In this project, I'll take you through the task of the car insurance modeling using Python and what are the process we are following here. The end goal of the car insurance modeling is to create a model that minimizes prediction error and provides valuable insights into the factor influencing car claim frequency or claim amounts. And the process I'm following for the car insurance modeling is first understand the business aims to achieve with the model, whether it's reducing risk, optimizing pricing, increasing competitiveness, or a combination of objective. And second, collect data from the internal system, claim history and claim records, and external source public vehicle records, geographical information systems. And third, create a new feature that might be predictive of risk of claim costs, such as aggregating past claim to calculate claim fraud or severity. Choose the appropriate statistical or machine learning algorithm based on the problem characteristics. Common choices might include linear regression, generalized linear model, decision tree, ensemble models, and ensure the model meets the business objective and the threshold. And to get started with the task of insurance modeling, we need dataset based on the car insurance claim. I'm given a GitHub link which will be useful for you finding a dataset for this task. You can download the dataset from the given link. Now, let's start with the task of car insurance modeling by importing necessary Python libraries and the dataset. The dataset contains of the following columns. So the objective of this car modeling task will predict the frequency of insurance claim made by the drivers. Now let's analyze the summary statistics and then move to the missing value and distribution analysis. Now let's proceed with visualizing the distribution and analyzing the categorical value. Our observation from the visualization, the age of driver appearance approximately normally distributed around 30s, and the car age also seems fairly normally distributed with slight right skew. And number of claims, most drivers have zero claim, indicating the right skew distribution, which is common in count data like insurance claim. The data preprocessing involves the region in the valuable in the dataset is categorical and should be converted to the numerical format suitable for modeling. One hot encoding is common approach we can use here. Once preprocessing is complete, we will proceed to build a GLM model focused on a Poisson or negative binomial distribution, as this is common for modeling count data like insurance data. The GLM means nothing but a generalized linear model. Okay, now let's start with pre-processing the data. The region variable has been one hot encoded, resulting in new variable regions suburb and region urban, with region rural being baseline category implicity. The data has also been split into training 80% and testing 20% set. So I'm giving a car insurance modeling for even frequency. For modeling even frequency, specifically for count data like number of claims, Poisson or negative binomial regression is typically used. The choice between them usually depends on the variance of the count data. Poisson regression and negative binomial regression. The Poisson regression assumes the mean and variance of the count data are equal, suitable when data does not exhibit over dispersion, and the negative binomial regression is more flexible, can handle over dispersion, variables will be greater than mean in the count of the data. We'll start the Poisson regression and check if the suitable model based on its fit and diagnosis. If needed, we can consider the negative binomial regression. Now let's proceed to build the Poisson GLM model using the training data. We'll consider age of the driver, car age, region suburban and region urban as predictors and number of claims as the response variable. The Poisson GLM has been fit with the following result. Constant represent the intercept. The estimate is 0.0906, but it's not statistically significant. The age of the driver, the coefficient is minus 0.0205, indicating that with the additional year of driver's age, that log of expected climb decreases. It's statistically significant, suggesting a strong relationship between the age of the driver and the number of the climb. Car age. The coefficient here is 0.0152, suggesting that the older cars tends to have slightly expected climbs, although its effect is statistically significant. The region suburban and region urban. The coefficient of this category are 0.0799 and 0.0861 respectively. Both are compared to the baseline rural category and indicate slightly higher expected class in suburban and urban areas. However, neither is statistically significant. This model suggests that the driver get older, the expected number climbs decreases significantly. There are some indicators that the car age might affect the number of climbs, with older cars having more climbs, but this isn't significantly in this model. The model does not find statistically significant evidence that is being suburban or urban region affects the number of clients compared to the being in rural areas. So the summary here. So car insurance refers to use of statistical and mathematical model to accurately predict events such as frequency of climb, the severity of climbs, or total cost associated with climbs, which in turn help in pricing insurance product, managing risk, and optimizing business strategy. I hope you like the project on car insurance modeling using Python. Feel free to ask valuable questions in the comment section below. Thank you.